Welcome to the integumentary system. This is one of 11 organ systems we are going to talk about this semester. The integumentary system is going to consist of your skin, which is, remember, a cutaneous membrane, plus all the appendages, otherwise known as accessory structures or organs, that are attached to it. So these are going to include things like sweat glands, which are also referred to as sudoriferous glands, sebaceous glands, otherwise known as oil glands, hair, and nails. In general, the skin is a combination of epithelial and connective tissues that are working together for some very specific purposes, which we'll cover in just a couple of slides. It is considered the largest organ in the body, on average being 1.5 to 2 square meters and weighing about 4 to 5 kilograms. Now, this is metric. As I mentioned, a metric is going to be important to understanding the science involved here, but just to give you a rough idea on the poundage, that is going to be approximately 12 pounds. Approximately 12 pounds, 11 to 12. Thickness is going to be variable depending on where we are in the skin, where that skin is on the body. It's going to range from about 1.5 millimeters to about 4 millimeters in thickness. All right, let us start off with functions. The skin, believe it or not, has a slew of different functions. First and foremost, it's going to be protection. It is a physical barrier and helps keep water in, maintaining water conservation. Remember, we are 70% water, so that's going to be important. And then it is also going to be important in keeping water out, because excess water is not good. That physical barrier is also going to keep pathogens and foreign particles out of the system as well. It is going to be involved in regulating our body temperature. It's both an insulator and a radiator, so it's going to help in both heating and cooling. Sensation. There are thousands, hundreds of thousands of sensory nerve endings embedded in our skin. These sensory nerve endings are going to pick up everything from pain to light touch to deep touch to temperature to all sorts of things. It is going to be involved in communication with other human beings. Signals, expression, touch, that's all part of communication. It is going to be involved just a tiny little bit with excretion. When you sweat, you are getting rid of water, salts, and some small organic compounds. This is not a major contributor to excretion. It is just a tiny contributor. Because it's a physical barrier, it is going to be involved in your immune response. However, there are some phagocytes that do hang out in the epidermis that are going to be an active component of that immunity. The dermis can act as a significant blood reservoir because of all the capillary beds embedded within it. And then also your skin is a primary factor in creating vitamin D. Vitamin D, we've been taught from a young age, is important for appropriate calcium absorption from the small intestines. However, we have learned in recent years that vitamin D is actually involved in a whole slew of different processes. So having enough vitamin D is going to be critical for overall health, not just bone health. All right. Let's talk about the architecture of the skin here. The skin is going to have two main portions. Now, you may have been told that the skin has 3 layers. That is true, but not true at the same time. 2 layers are considered true skin. The 3rd layer is considered almost like an attachment. It's not truly considered a layer of the skin, but we talk about it with the skin because it's the best place to talk about it. So, first 2 layers. That's going to be your outer epidermis, followed by the dermis. That false layer, or that kind of is, kind of isn't layer, is the hypodermis, also referred to as the subcutaneous layer, depending on what textbook you're looking at. So the epidermis is going to be about 4 to 5 layers of epithelial cells. This is stratified squamous epithelium. This is avascular, and the skin layers on top are going to be dead. They're keratinized, full of that hard keratin protein, and they are dead. It's that bottom layer that's going to be alive and is going to be constantly splitting and creating new cells, pushing them up towards the surface. The second layer is referred to as the dermis. This is going to be composed of our areolar and dense irregular fibrous connective tissue. This is where we are going to find the receptors for a wide variety of those sensory senses. This is where we're going to find hair follicles, nail beds, all of that fun stuff. That third layer, as I mentioned, is the hypodermis or subcutaneous tissue layer, literally beneath the dermis. This is going to be composed mostly of adipose. And this adipose layer is either going to be next to another adipose layer, depending on where it is in the body, or muscle or bone. This adipose layer is going to be one of the contributors to the body helping to regulate warmth, helping to keep in warmth. So starting off with the epidermis, as I mentioned, it's keratinized stratified squamous epithelium. We are going to have 4 cell types found within this layer. Primarily, 90% of them are going to be keratinocytes, filled with keratin, waterproof barrier. Second type, contributing to about 8%, is going to be our melanocytes. Melanocytes are going to be what produce melanin. Melanin is a pigment that absorbs UV radiation. The melanocytes are going to pass melanin to keratinocytes. Melanin is what gives our skin our color. Now, everybody has the same number of melanocytes. We're all born with, let's say, 100. It's more than that, but 100 is a nice round number. The difference between one person's pasty pale skin and one person's nice dark skin is how much melanin their melanocytes pump out, because they have the same number of melanocytes. That's the only difference. Now that difference, though, is coded in the genetics. So the amount of melanin produced under normal circumstances is a genetic component. Now the remaining 2% is going to be divided between Langerhans cells and Merkel cells. Langerhans cells are going to be phagocytes. These are immune defense cells. These guys are easily damaged by UV radiation. So the more UV radiation you expose your skin to, the more you're going to damage these cells, which means the more your skin's immune response is going to be compromised. And then Merkel cells are found in the deepest layer of hairless skin. So any place where you don't have skin. So that's for the most part going to be places like the palms of your hand and soles of your feet. And these are going to be involved in sensory transduction, aka touch. Keratinocytes are going to be connected to each other by desmosomes. Desmosomes are also referred to as tight junctions. They help provide continuity, strength, stability, and protection, making sure nothing can slip between the cells and also helping to make sure the cells can stay together regardless of stresses. So, these desmosomes are also part of the reason that when you're peeling, let's say you burnt your skin and now you're peeling, it comes off in sheets rather than individual cells. So even when we're like, oh, I'm flaking, those are actually small sheets. They're not individual cells. Everything up here, I have already actually mentioned. All right. As I mentioned, new cells are going to be made in the deepest layers, and as they are created, they're going to push older cells up towards the surface. By the time they get to the very top layer, they are dead and nothing more than keratin bags. Melanocytes, as indicated here in this microscope image, look like spider-shaped epithelial cells, which, as I mentioned, synthesize melanin, the protein pigment. They're going to be found in the deepest layer of the epidermis, so that very bottom layer. They package melanin, and it is then transported in membrane-bound granules that are referred to as melanosomes. These granules are then transferred to keratinocytes in the bottom two layers. So if a skin cell has not received one of these melanosomes while it's in the bottom two layers, it is going to be pale. It is going to be pigmentless. These granules are going to accumulate on the sunny side, quote unquote, of the keratinocytes, aka the top side, because remember, these pigments are going to help protect against UV radiation. So if they're below the nucleus, they're not going to protect the DNA from that radiation. As long as they're above the nucleus, they're going to work to protect the DNA. This is going to help protect against mutations. Here's keratinocyte, here's a melanocyte. This is an example of a Langerhans cell, and this would be a Merkel cell. All right, cell layers. The bottommost layer of the epidermis is going to be the stratum basalli. This is going to be firmly anchored to the underlying dermal layer. It's a single layer, actually, of cuboidal columnar cells with melanocytes and Merkel cells interspaced, as we can see here. As these cells split, they're going to undergo mitosis to do that splitting, and they're going to push the older cells up towards the surface. Next layer, this one right here, it's actually one of the thicker layers, is going to be stratum spinosum. This is actually 8 to 10 layers of cells that are closely packed together. We're going to have desmosomes in here, we're going to have Langer cells in here, and as the cells move through the layers of the stratum spinosum, they're going to get flatter and flatter and flatter, and they're going to get fuller and fuller and fuller of keratin. When we get above the stratum spinosum, we're going to enter into the stratum granulosum layer. The stratum granulosum layer is again going to be about 3 to 5 layers of flattened cells. They're still a little bit alive. We're not quite into completely dead yet. However, by the time they get to the top layer of the stratum granulosum, the nucleus is going to break down and cell death is going to be initiated, apoptosis. This cell death, however, is going to be modified, because normally when a cell is undergoing apoptosis, it is going to completely break down, be destroyed and dissolved, and everything in it reused. With the stratum granulosum level, when we have apoptosis, they're actually going to stay. They're just going to no longer be doing any metabolic things. So the nucleus breaks down, mitochondria break down, all the organelles inside break down. It's no longer going to be creating proteins, carbohydrates, fatty acids, anything like that. We are going to be nice and full of keratin and other granules, which are going to aid in that waterproofing element. Now, if we are looking at the thick skin in the palms and soles of the feet, we would then encounter another layer, which is referred to as the stratum lucidum. This is another 3 to 5 layers of clear, flat, dead cells that are going to be full of keratin. However, all skin is then going to finish with a stratum corneum layer, which is 20 to 30 layers of flat, highly keratinized dead cells. That outermost layer, or layers, depending on how aggressive the abrasion is going to be continuously shed and replaced. Your skin cells replace themselves every 2 to 4 weeks. So every 2 to 4 weeks, you have a new layer of skin. New coating of skin. Right. Stratum corneum. This layer, right, that outer layer right there. It is going to help protect against mechanical abrasion. Cells are going to absorb impact and simply flake off as necessary. Because they're tightly packed, dead, they're going to help prevent pathogen entry. And they're also nice thick layer, going to help prevent against desiccation or drying out of the bottom layers, and therefore yourself. Here we have a couple more images of these various layers. Here's a microscope slide of it. Okay, skin color. As I mentioned, melanin is going to be a pigmenting color of your skin. However, there are two other components that are going to aid in or contribute to your skin color. Keratin and hemoglobin. So let's talk about melanin first. Melanin is the only one that's actually made in your skin. It is going to be a polymer of tyrosine amino acids. It's going to involve an enzyme called tyrosinase. And if you are someone who is considered an albino, not just pale skin, but albino, actual white skin, typically they're also going to have white hair and usually red or pale blue eyes, very pigmentless features. The reason they are pigmentless is because they lack this enzyme. So typically, skin color is going to range, and melanin is going to range in color from yellow to reddish brown to black. As I mentioned, we all have the same number of melanocytes. It's just how much they make, how much melanin they make. Also, another contributing factor in skin color is going to be the type of melanin they make. And again, this is all going to be coded for within the DNA. Freckles, moles, these are local accumulations, concentrations of that melanin. Now, keratin is a yellow to orange pigment found in plant products such as your carrots, and large quantities of keratin, when consumed, will be deposited in the stratum corneum layer of thick skin. That's why you can get a yellowish tinge to the palms of your hands and the soles of the feet. But it takes a lot. It takes a lot. So, if all you're eating is carrots or peppers, orange red peppers, maybe, but it takes a lot. Now, hemoglobin, on the other hand, hemoglobin is a pigmented protein that is found in red blood cells that aids in red blood cells transporting oxygen within the blood. So this protein, this color compound, is actually found in your bloodstream. So, how does this contribute to your skin color? Well, the fairer your skin, the more the crimson color of oxygenated blood is going to radiate is not the right word. The more it's going to be visible through that paler, fairer skin. So that's why typically Caucasians, they tend to have a rosy pink hue to their skin. It's because you're actually seeing light wave-wise the blood vessels in the skin, and that's giving it a pink tone. All right, now, because we're talking about skin, look at your arm, and you will see a bluish line or lines, depending if you're looking up more towards your elbow or you're looking more down towards your wrist. You see these bluish lines. That's your veins. Here's the thing. Your blood is not blue, contrary to every single artistic rendering of the cardiovascular system you have seen. What's actually occurring is that when red blood cells aren't carrying oxygen, they're turning a dark red, blue, purple color. The reason you have a blue or sometimes a purple, very occasionally people will be like, nah, my vein's green, is because that is the light waves reflecting off of the veins, off of that deoxygenated red blood cell, coming through your skin, and that is the light wave spectrum that's actually being picked up by your eyes. That's why it appears blue. We can actually use the color of your skin and exposed mucous membranes to give clues as to your oxygen status. So if your lips are starting to turn blue, that's typically an indicator that you are not receiving oxygen. You have a lot of deoxygenated blood flowing through your lips. If your nail beds are starting to turn blue, places that have a ton of nail beds close to the surface, they're starting to turn blue. Maybe your hands are starting to turn almost ice white when they aren't normally. Indications of lack of blood flow, lack of oxygen. So we do have some terminology when it comes to skin color. If we say that somebody has erythema, this is referring to skin redness. This can occur very naturally due to the fact that you've just been exercising or you're embarrassed. But it can also be a side effect of high blood pressure, certain medications, inflammation, etc. Pallor, or pallor, depending on your enunciation, is what we refer to when people are very, very pale. This can be due to cold temperatures. They're cold. When you are cold, blood is going to leave your skin, trying to condense and consolidate inwards. This can be due to stress. This can be due to anemia. Cyanosis is what we refer to when your skin is starting to turn blue. It's taking a bluish tinge. This is going to be due to a lack of oxygen flowing into that tissue space. Babies, if they're not breathing, turn blue. Heavy smokers, people with emphysema, any respiratory, especially chronic respiratory condition, circulatory issues, all can have cyanosis. Jaundice is when you have a yellow-orange tinge. This is going to be very common after you have an internal hemorrhage or bleeding. The liver is what's going to break down and remove those red blood cells from the tissue spaces. And when you have an internal hemorrhage, you have a ton of them, and the liver is going to have problems breaking down and then getting rid of all of those byproducts. So those byproducts are going to accumulate, and that's where you get that yellow-orange tinge. It will go away as long as you have a normal, healthy liver. It's just going to take a little bit. Bronzing. This is when your skin takes on a metallic appearance. This is typically a sign of Addison's disease, which is a hypofunction or a low-functioning adrenal cortex. If you have blue-black bruises, we refer to those as contusions. And then here we have skin grafts. Skin grafts are a fantastic tool that we use. If the area of skin is significant enough that it's struggling to regenerate and fill in that space, we can remove tissue from a different site on the person and cover that space, sew it in, tie it in, and it will actually heal the space and replace the skin that's struggling. Now there's a couple terms here. Autograft is when we take it from the person that is receiving it. Same person, can be from a different site, or we can grow it in a petri dish first. But the cells that we grow come from the person. Isograft is when this donation comes from an identical twin. Homograft is from when the skin comes from another human being. Could be another family member, could be just somebody completely different. And then heterograft is when we use the skin from an animal. This would be things like pig skin. There's been, with burn victims, a specific type of fish skin that has been fantastic with healing with minimal scarring burn patients. I forget the name of the fish. It's from South America. But that would be a heterograft, skin from an animal.